Picture this. It's 11:59 p.m. You're scrolling through your phone, maybe watching a late-night video just like this one. Outside, the world is calm. Stars twinkle. The night feels ordinary. No explosion, no warning, just a silent implosion. And in the blink of an eye, our life-giving sun becomes the most terrifying object in the universe, a black hole. And then, without warning, the unimaginable happens. Somewhere, deep inside the heart of our star, physics itself twists. The sun's radiant glow collapses inward, vanishing in an instant. To find out, we need to understand something about how the universe works, because the truth might surprise you. If the sun suddenly turned into a black hole of the exact same mass, gravity wouldn't change, not at all. That's right. The Earth wouldn't get sucked in. We wouldn't be flung out into space. Our orbit would stay exactly the same, as if the sun were still there, shining proudly in the sky. But that's only half the story, because while gravity stays the same, the light would be gone. And 8 minutes later, the time sunlight takes to reach Earth, our world would be plunged into eternal night. So what happens next? Would Earth be torn apart? Would we spiral into the darkness? Would we even survive long enough to see the end? At first, you might not even notice. Streetlights would still burn, screens would still glow, and the moon, for a while, would shine softly with borrowed light. That's the moment humanity would truly understand what it means to lose a star. The final sunrise we'll ever see would have already passed without us knowing. Above us, where the sun once burned, you'd see nothing at all. Just a blank patch of darkness, except, if you looked carefully, a faint, distorted ring of starlight might appear around it. That's the Einstein ring, created by gravitational lensing. Light from distant stars would bend around the black hole's immense gravity, forming a ghostly halo, a cosmic echo of what we once called the sun. But make no mistake, beauty aside, the countdown to extinction would have already begun. Because sunlight isn't just light, it's the heartbeat of everything alive. But soon, the sky would shift, the moon's glow would fade, and then, one by one, the stars would reclaim the heavens, sharp, countless, and cold. Oceans would start to crust with ice. The thin layer of warmth we take for granted, gone. Our atmosphere would begin to change, collapsing slowly as the planet cooled. By the end of the first year, the global average temperature might hit -70 degrees C. That's colder than Antarctica on its worst day, everywhere. Within days, photosynthesis would stop. Plants, unable to feed themselves, would begin to wither. Within a week, temperatures would plummet far below freezing. Humans, of course, would fight to adapt. We'd gather in underground cities powered by nuclear energy or massive geothermal plants drilling deep into Earth's crust. Artificial suns, massive mirrors, or orbital reactors might keep small colonies alive. But make no mistake, it would be survival, not life. But Earth wouldn't die instantly. Beneath the ice, deep in the ocean trenches, heat from the planet's core would linger. There, near volcanic vents, microbial life could still survive, the last beating pulse of a frozen world. And while we fought to stay warm, the planets around us would continue their silent orbit, perfectly balanced around the invisible heart of the solar system. The black hole that replaced our sun would be tiny, about 3 kilometers wide, roughly the size of a small city. But its mass would be exactly the same as before, 1.989 times 10 to the 30 kilograms. Mercury, Venus, Earth, Mars, all still circling nothingness. Because gravity hasn't changed, only light has died. A teaspoon of that material would weigh more than Mount Everest, and its gravitational pull would distort space itself, a pit in the fabric of reality. To put that in perspective, that's 330,000 times the mass of Earth squeezed into something you could drive across in 5 minutes. So, in this nightmare scenario, the planets wouldn't immediately fall in. They'd keep orbiting for millions, even billions of years around this invisible core. But the thing about black holes is, they're not cosmic vacuum cleaners. If you stay at a safe distance, they're as predictable as any other mass. But eventually, chaos would creep in. Without the sun's solar wind, the stream of charged particles that pushes away dust and gas, space would grow messy. Asteroids, comets, and interplanetary debris would start to drift inward, and some would fall victim to the black hole's pull, forming a thin, glowing accretion disk. From far away, the solar system would look eerily normal. Tiny spheres tracing their paths through the dark, no longer bathed in light. That disk, swirling with superheated matter, would glow faintly in X-rays. For a brief moment, our dark sun would shine again, a ghostly blue light radiating from its destruction. If we could see it, it would be hauntingly beautiful, like a halo made of fire and gravity. But deadly. Any spacecraft nearby would be vaporized in seconds. Over centuries, the atmosphere would collapse, turning into frozen layers of nitrogen and oxygen. The sky would be clear, empty, and utterly black. And yet, Earth would keep spinning, a dead planet tracing its perfect orbit around a star that no longer shines. It's a chilling image, a cosmic tombstone to what was once the cradle of life. But as grim as it sounds, there's comfort hidden in this thought experiment. Meanwhile, Earth would slowly freeze solid. The oceans, now frozen over, would trap the last heat beneath layers of ice kilometers thick. A black hole needs at least 3 times the sun's mass to overcome the outward pressure of atomic forces that keep it from collapsing. Our sun doesn't even come close. So this isn't a prophecy, it's a story, a way to understand what gravity really means and how fragile our balance with the universe truly is. Because the sun cannot turn into a black hole, it's simply not massive enough. When it dies, billions of years from now, it will swell into a red giant, then collapse into a white dwarf. It's what keeps the planets dancing, what shapes galaxies, and what, in the end, swallows stars whole. And yet, the same law that holds a black hole together also keeps your feet on the ground. It's the quiet force that unites the grand and the ordinary. That's the poetry of astrophysics. The same gravity that births galaxies also holds a cup of coffee to your table. We're made from the same fabric, the same laws as everything out there. Because gravity is more than a pull. It's a conversation between everything that exists. Matter bending space, space telling matter how to move. And that's why this thought experiment hits home, because it reminds us how much we depend on something we barely think about. So when we imagine the sun collapsing, what we're really imagining is the end of connection, the end of light, warmth, and the endless conversation between energy and life. The sun doesn't just light our sky, it defines time itself. It sets our rhythm, our seasons, our existence. Without it, even the stars lose context. The universe becomes a cold painting, beautiful, yes, but silent and still. So next time you feel sunlight on your skin, remember, it's not just warmth, it's history. It left the sun 8 minutes ago, traveled through the void, and found you. In that sense, every photon is a message from a star that has been burning for 4.6 billion years, holding chaos at bay so that life could wonder about it. Every sunrise you've ever seen, every shadow, every heartbeat, all powered by the same fusion engine 93 million miles away. And if one day that light fades, if the sun ever truly turns to shadow, then at least we'll know that for a brief cosmic moment, we lived in the warmth of a star that chose to shine.